Okay, so that's user studies. The next thing you might do is a field study. So if we go back, just recall that there's three types of studies. So the user studies with the general population. Now we're talking about a field study. So this is where you're going to deploy it to your actual users. I won't spend as much time talking about it. But the idea here is that you deploy so a common way of doing this is called A/B testing, which is just like in the user study, you divide your users into two groups. So for example, A gets the solution and B doesn't get it. And then you're basically going to do all the same stuff you do in your user study. Okay, so what are the pros and cons of a field study? Okay, so the big pro is that it's representative. You get a good sample. The people are exactly the people that are going to use your system anyways, and so you get strong representativeness. Because people are using it for real, like say it's in a corporate environment, they're actually using it in terms of doing their job. You're not bringing them into the lab, watching them with a clipboard. You just push the tool, they have it, they're doing their day-to-day stuff, they're doing it the same place that they normally work. They're just using your tool as opposed to not using it. So you have strong ecological validity. You can have a large user base. Usually it doesn't matter, like once you do all the work to set up your field study, it doesn't matter if you push it to 10 people, 200 people, or 2,000 people. That's the number of people that are going to use it. Unlike a user study, whereas every additional person is another 30 minutes of your time and another $200 that you have to pay them or whatever. So yeah, you can have a large user base that it's sort of like, it doesn't matter how big it is. Another thing you can do is in a user study, you have about 30 minutes with someone. In a field study, you can make them use this tool for 3 months. So you have a longer time period. Then you can start looking at fatigue. Does the user fatigue after a while and things like that. So you can see if they acclimatize to the tool, if they get fatigued of it, that kind of thing. So there is a difference between, yes, like people have a high tolerance for 30 minutes of something. It can also be more extreme than that. Like, here's an example that has something to do with security. Okay, so everyone knows Coca-Cola, the drink. There's Pepsi, so they're competitors. So I forget when it was. Let's say it was in the 80s. what Pepsi started doing is they would go into supermarkets, and Pepsi's like a little sweeter than Coke, or at least in the 80s it was. It tastes different. It has a different like taste profile. So what Pepsi realized is we're going to go into supermarkets and we're going to give people what they call the Pepsi challenge, where they give them 2 cups, one's Coke, one's Pepsi, but they're not labeled, and they challenge them to see which one tastes better. And then at the end, more people prefer Pepsi than to Coke, even if they're Coke drinkers, because in that small little time window, you're just having a sip, the sweetness or whatever, it tastes better to people. Then Coke got really mad about it. And so what they decided to do is reformulate Coke. So it used to be called Coca-Cola Classic, and then they came out with what was called the New Coke. And so the New Coke, they spent a long time doing user studies. So they bring people in the lab, they would try different recipes, and eventually they got something that would beat Pepsi. So most people would if you do the Pepsi challenge with this New Coke, they're going to like the New Coke better than Pepsi. Okay? So then they thought they won the Cola Wars. So they brought out this New Coke, they rolled it out, and they started doing the Coke challenge, right, in grocery stores, and people like New Coke. Now, the problem with New Coke is it actually tasted good, apparently, if you have a sip of it. But once you have a can of it or you have a case of it, it starts to get kind of syrupy, and it's too sweet, and it's kind of citrusy, and it's gross. And so people, after a month, hated it, right? Everyone wanted the original Coke coming back, okay? So the lesson there was, because you had like a small sample, what you like is going to be different than if you're drinking it every day, right? And so software is kind of like that. If you might have like some really high usability features where like the software is really going to hold your hand and make sure that it walks you through. And you might love that at first, right? Because it's making your life easier. But after a month of it, you get really irritated with it, right? Like there was one thing that was much maligned, once again, not about security, but at least about software, is Microsoft Word had this like thing called Clippy. I don't know if anyone remembers, but it's a paperclip animation. It would show up in the bottom right of your Word document, and it would talk to you as you were trying to write your document. Like, oh, hey, like, do you want to make that bold? Like, I can help you with that, or I don't know what all it would say. And so anyways, that's the kind of thing that actually is a really good idea, right? It's there. It's going to help the user. They don't have to read the manual. They don't have to go through help looking through things. But over time, it gets a little irritating, right? And once you know Word and you know what you're doing, then it's just in the way. It's kind of dancing around, and you just want to get rid of it, okay? So people's attitudes change over time. So if you can do some sort of longevity study, then yeah, you might get a very different response after 3 months of someone using something than after 30 minutes of using something. So a field study is a really good way to get that longevity. The other thing you can do is in 30 minutes, you can only look at like a narrow set of tasks. But with a field study, you're going to let them use it for 3 months. You can see how they use it in lots of different dimensions. So you can examine a broader set of hypotheses. Okay, so this sounds great. It actually is great. Like it's strict. It's in terms of actual like usability properties, it is better than a user study in all regards. Okay, the only con really of it is just that it's hard to arrange. Okay, it's expensive and things like that. So so logistically, it's hard. You have to get it polished enough that people are willing to push it. You also have to instrument it, so whatever your data you're collecting, it has to phone home with that data. You might have to, even though some of your users are going to use the current system, it might not be collecting data. So you have to instrument the current system too, so that it's collecting data, and then all this data is flowing back to you. So it's logistically hard. It needs to be instrumented. For data collection. Yeah, it needs to be a highly polished solution. So if you have some crazy idea and you just want to test whether it works with users, you can't use a field study for that. And so, yeah, you have to convince a company to do it if you're a researcher or something like that. So one study that I really liked, actually some colleagues at Polytechnique here in Montreal, they did it. They actually gave people laptops. Actually, it was a collaboration, I guess, between them and Carleton. But they had a study where they would just give someone a brand new laptop. And so they were able to fund it, but then they did some instrumentation of the laptop. And so they were able to collect a lot of data about like how often do they get malware infections and things like that, and how did they do it. And the other thing, going back to the ethics clearance, you have to think about privacy. So you're giving someone a laptop, but as researchers, you don't want to know everything that they're doing on the internet. And so you need to, have some like privacy built in. So you're collecting some kinds of data, but you're not collecting everything. Maybe you anonymize it. And then where does the data end up? Who holds it? So these are all the issues that they had to think through. And it was just like a large scale project because normally you don't have the money to give everyone a laptop. But they were able to do it. And so, that was a nice paper. Maybe I'll link to it on the course website if you want to read it. But anyways, okay, so that's field studies. Then we'll talk about expert review. Okay, so before I said it's a usability expert, actually what we prefer is what we call a dual expert, meaning they are an expert in usability and they know something about the system. Or solution, I guess is the term that we're using, being tested. So an expert review, you don't just pick a random person off the street. Okay, this is like before you do your user study, before you do your field study, you want to just get a sense of what the software is about. You get someone who knows a lot about usability. They know how to do a formal usability analysis, but they also know enough about the software that they know that, oh, this might be a problem, right? This looks like there's a chance the user is going to click on this, and I know what that will do. I know that that leads to a dangerous error, or whatever the case may be. So you have to know enough about the system to know that that's something that needs to get flagged if you're going to flag it. Okay, so that's why we look for dual experts. Okay, so the pros and cons. So it could be cheap, usually cheap because you're only paying one person to do it. Now, because they're an expert, maybe you're paying them a lot, but it's probably cheaper than paying 200 people in a user study, and it's probably much cheaper than running a whole field study. It's very fast. You don't have to do a lot of preparation. You can just do it. In fact, we'll do it probably next class, but we'll just do it off the top of our heads or whatever. So it's you can do it right away. You can look at a broader set of issues than you could in a field or in a user study. So in user study, you have that 30-minute window. Expert review, first off, because you're an expert, you can go through the system a lot faster than someone off the street can do. And then you're not limited to 30 minutes. You can say it for 4 hours or 5 hours or whatever it takes. So you can cover more of the system or solution in greater depth. Than a user study. So in a field study, you could maybe do it comparably because you have a couple months or whatever, but especially relative to a user study, this is kind of like your rapid prototyping where you do it. The main drawback is that the expert isn't a real user, basically by definition. So they're going to make errors. So there's two types of errors, and basically false positives, false negatives. So they could miss things that real users miss problems that a real user would have. Or on the opposite side, they might flag too many issues. There might be a whole bunch of issues that they flag that aren't actually really issues. Now, generally, that's not a problem. You can fix everything, but it takes time, right? And so if they're flagging a whole bunch of stuff and it's not actual problems for your real users, then you waste a lot of time and money fixing things that didn't need to be fixed. So I'll put issues in quotes, so too many issues that aren't really problems. And so this leads to time and money to fix. Okay, so there's there's two main kinds of expert reviews. There's probably lots, but the two main ones, one of them's kind of fallen out of favor, but the one that we'll study is called a cognitive walkthrough. Yeah.
What's the typical education of an expert reviewer?
Sorry, what's the
typical education of an expert reviewer? Would they just already be in the field and then just be interested about usability?
Yeah, so I guess it depends where they're coming from. So if it's a company corporate setting, it would probably be an employee that knows the product well. So it could be someone from sales. It could be a developer who helped develop it. It could be a user of it. It doesn't really matter. And then they would have some background in usability as well. If it's in academia, then yeah, you would try and find someone. You can also do it with more than one person. These things work. So I said one person, but you might use two. And there you might have one person who knows usability and one person that knows the system. So it would just be like they have a research background in the system. They would know something about what they're studying. Yeah. All right, so methodology. So the one we'll study is called a cognitive walkthrough. Okay, so before cognitive walkthrough, I'll tell you the approach that was suggested earlier, but it didn't really work. It's called heuristic evaluation. And basically what it meant is you would, I'll put it in terms of software because it was developed for software, but once again, you can use it for more than software. In heuristic evaluation, you would just look at every button and you'd say, okay, what does this button do? When's the user going to use it? Do I think they know what it would do? Does the icon look like what it's supposed to look like? They might go through every menu option and look at every menu. So it's a real top to bottom look at every aspect of the user design or the user interface of software. Okay, so that's heuristic evaluation. Cognitive walkthrough says heuristic evaluation is kind of a waste of time. Most users have a task that they want to do. And so instead of studying every nook and cranny of the entire user interface, why don't we take a more task-oriented approach? So we're going to say, I'm pretending I'm a user and I want to do some basic task, right? I want to open a document and copy and paste some text into it, which you will not do on your project reports. So then I'm going to basically walk through that procedure. Okay, I'll try it. I'll see what the right procedure is. I'll see where I think users might go wrong. And I'm going to impose some structure on it so that it's not just a free-for-all in terms of what you're doing. But anyways, the core idea of a cognitive walkthrough, why it's called a walkthrough, is you have an expert. They're going to pretend to be a user. You define a set of core tasks. To be evaluated. So you're not worried about every button in the user interface. All you're saying is at the end of the day, do I think a user could do this core task or not? Or what do I think are the problems or the pitfalls that a user will do if they try and do this core task. So a core task is kind of like the most common. Well, at least you definitely want to start there, but then later, if you want really good usability, you might look at less common tasks. But you're going to start with the most common tasks. All right, so start with the most common tasks. And then in order to give you some structure, what you're going to do is you're going to have a set of guidelines that should always be true as you're walking through this task. Okay? So that sounds kind of vague. I'll give you examples. So you define a set of guidelines, or heuristics they're sometimes called. That define what you expect from the usability of the system. Okay, so for example, like the user always knows what the next step is. So the user has some goal and they can figure out what they should do next. Maybe the user can recover from any error. So let's say they make a mistake, then they can recover. Maybe you want to be stricter, like a user will never commit an error. Other things like user knows the status at all times. So they're trying to do a task. Do they know whether they've successfully done it or not? Do they know that they're halfway through? Do they know? Do they know what the next step is? So, like I said, does the user interface guide them? Does the user interface use a lot of jargon so they don't understand what it means, technical terms and things like that? So I'll show you, we'll do a toy example of the cognitive walkthrough next class, and I'll show you a set of actual concrete guidelines. Okay, so now you have your set of core tasks, you have your set of guidelines. Now you're going to basically just walk through the core task. Pretend to be the user doing the core task, and then you're always going to check in with the guidelines to see how you're doing. Okay, and then you're going to say something like, okay, so I did this small, like you won't describe the whole step at once, right? The step will be broken up. The core task will be broken up into smaller steps, but you'll be like, okay, now the user wants to do this step, right? This is what I'm seeing. I'm seeing that probably the user can figure out what to do next, but if they make a mistake, they can't recover from it, so I'm going to flag that. But I don't think they'll commit a dangerous error, and there's no jargon that's used in this screen and blah, 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 right? So you basically, for all the guidelines, you say both it's good in terms of this guideline or it's bad in terms of this guideline. So you flag, and then you want to pay most attention, obviously, to things that you flag that are where it doesn't match the guidelines. Okay, and you're not thinking of a single user, you're thinking of kind of a spectrum of users. So you might think like, well, 80% of the users, you don't have to put numbers on it, but you're thinking in your mind like most users will probably be able to navigate this, but there'll be some of them that won't be able to navigate it. And you might think just sort of generally like if lots of users can go through, or what kind of expertise would the user need in order to make the right decision about this. And your job isn't necessarily to solve all the problems as the person doing the evaluation. It's just to sort of raise the issues, hand it off to the developers or whoever, the manager, and then they can decide about what to do about these types of things. Okay, so just a quick recap. So generally, a field study is better in terms of usability than a user study. And in terms of usability outcomes, like how certain you are, it's better than an expert review. So this is in terms of usability outcomes, or maybe a better way of putting it is your confidence in the result. Okay, and then the other thing is that people often use more than one. So you don't have to choose between them. You can do all of them. Okay, so it's right. So almost everyone who does a user study did some sort of expert review first. Right? Like you have to at least think, you have to put yourselves in the shoes of your users before you decide what you're testing and what your hypothesis is, right? So you might like do the expert review, 50 times, trying out different things, and then you do a user study. And then you look at the user study and you see the results, and you see, oh, there's something interesting there, but it's not quite significant, or I asked the wrong question. I'd have to ask it, or I'd have to really look into this. I'd have to get them to do something a little different in order to really understand like what the difference is that I'm seeing here. So then you might play around with an expert review another couple times. So you might do this another 10 times. And then you might do another follow-up study. And now you're really happy, your results look good, and then you might try a field study. Or you might just publish at that point, depending on what sort of environment you're in, or whatever. Okay? So anyways, expert review, quickest, easiest to do, but the least robust results. User studies are kind of hard to do, but you get better results. Field studies are really hard to do, but you get really good results. Okay? So you just sort of walk through them. Okay, so next class what we'll do is we'll do an actual cognitive walkthrough. I'm going to do it on Tor. It's something I studied a long time ago, and so every year I just try to do it to see how Tor's improved in terms of their usability. And so I'll show you the core tasks, I'll show you the guidelines, and then we won't spend forever doing it, but we'll install it and start to use it and try and actually do it. All right, so I'll see you all next week. All right, we'll get started. Okay, so first off, there's a question about the assignments. I talked to the marker today. She wanted a few more days, so she's hoping to get it back to you by Friday. As a reminder, your mark will come back to you through EAS, so you'll just get it automatically. Okay, before we start, is there any questions about anything, content from last week? Your next assignment I'll give to you next week. It will be doing what we do now. So doing this cognitive walkthrough, I'll ask you to do it on a different tool than the one that we do in class, but you'll do the same process. So being here is useful for getting a head start on assignment 2. Okay, so seeing no questions. So just as a reminder, we're talking about usability. So how do you tell whether a system, and particularly a security system, is actually usable? And if it's not usable, then you could have problems because users might not use it. They might try to circumvent it. They might not use it correctly. They might make dangerous errors. So there's different things that could go wrong. And in the worst case, if you had an unusable system, then you might as well just not have a system at all, right? It's no better than not having a system at all. So usability could kill your entire experience for your users, which could actually end up not achieving like what you want from a security perspective. So we talked about 3 methods to evaluate usability. So one is you can pull users into a lab. You can get them to experiment with whatever you're testing the usability of. So that's called a user study. If you had a polished solution and you wanted to test it at scale, if you say you work in a company, you could roll it out to half of your users or something like that, and you could test it. So that would be a field study. And before you do either a user study or a field study, what you should do is think through the usability for yourself. And so you might use expert review. So expert review is just one person, or maybe you have a team of a few people. They look at the usability of the software. They usually know how the software is supposed to work, so they're not novices. And they also know a bit about usability and what the principles are for usability. Okay, so the cognitive walkthrough is where you define a set of tasks that you want to do, and you just go through the process of basically doing those tasks. And then at every step away, you ask yourself some questions about usability. Okay, so we'll do a concrete example. So we'll use Tor. Tor is an anonymous browser for your for the internet. So basically, you can visit websites and it will hide your IP address. I looked at Tor personally when I was a grad student. So when I was your age, I had a course project and I decided to do a usability study of Tor. And so that was, 15 years ago. So I'll give you what I did 15 years ago, and then we'll redo it in class. And a lot has changed, as you can imagine, in terms of the software itself. But before we do, let me tell you a bit about Tor and how it works. So remember, we want to be dual experts. So we want to know a bit about usability, and we want to know a bit about what we're studying. So I'll try and paint a picture of what it does, which will be useful when we look at the usability of it. So first off, it's software, if that wasn't clear. Okay, so it's something we're going to download, we're going to install it. I don't have it installed on this computer, so we'll do everything from scratch. And basically what it's going to do is it's going to provide you some level of anonymity when browsing the web. And what anonymity in this context means is it's going to hide your IP address. Okay, does anyone else know a way of hiding your IP address? Okay, so the most common is to use like a VPN. So let's compare and contrast Tor to a VPN just so you can see what the differences are. It uses the same principle, it has a little bit stronger anonymity. So let's say we have a user. And we have our VPN or proxy server. And then we have the actual resource, the actual website, Google, Facebook, whatever it is that we want to access. Okay, so in a VPN, it's really simple. It just forwards your traffic. Okay, so the user would make a request to, say, Facebook. But what they would do is they would configure their browser so that it would make the request to the VPN instead. Or they would configure their operating system. We'll talk about it. But somehow the user's client knows to go to the VPN instead. So it would send a request, and then the VPN will basically just forward the request. Then the server will give a response, and the VPN will forward the response to the user. Okay. Now, why does this provide anonymity? So the user has an IP address, and the IP address is tied to the request. Okay. So in the envelope that contains the request, the IP address is written on the outside of it. Why? It has to be there because when the response comes back, you have to know where to send it. Okay? So you have to say, this is where I want the response to come back. Could you write someone else's IP address on it? You could. So that's called IP spoofing. In that case, would the response go back to them instead of you? And the answer to that is sort of complicated. What we're talking about here runs over what's called TCP. And in TCP, you first have to do a full round of communication before you start sending requests. And so if you spoof an IP address, you won't be able to complete that round of communication. It will try and complete it with the other person, and the other person doesn't know anything about, creating this TCP connection, and so they'll just ignore it and drop it, so it will never get formed. If you use UDP, UDP is where you don't have a connection. You send a request and it sends a response. There's no setup. This is used more for like streaming video, that kind of thing. Then you can spoof it. We did talk about spoofing like way back in the very first lecture when we talked about amplification attacks for denial of service. So you might remember that. But anyways, everything we're talking about here is like HTML, which is running on HTTP, which is running on TCP. Okay, so you can't spoof IP addresses. Okay, so you put your IP address on the request, and this is the IP address of the user. And so what happens is when the VPN forwards your request, it puts its own IP address on it instead of yours. Okay, so the idea is that Facebook or whoever is here, they only see the IP address of the VPN. Okay, so they have no idea who the user is. The VPN, on the other hand, they know who the user is, and they also know where the traffic's going. They know that it's ultimately going to Facebook. Okay, so the VPN is capable of, whether it does this or not, it's capable of keeping basically a log that says, okay, this is the user IP, and they were going to Facebook. And then for every site that you go to, they could fill this log out. Okay, and then maybe law enforcement is interested in that at some point, so they could go to one party, the VPN, and they could get this log, and then they would be able to trace users, so it's not anonymous anymore. It could also be the case that the VPN is law enforcement itself, right? You don't know, sometimes you just choose a VPN randomly online, you don't really know who's running it. It doesn't have to be law enforcement, it could be people that are selling that information, so they're selling it to a third party who wants to know what IP addresses are visiting different websites, things like that. So people generally use VPN when they want to hide their IP address, or the other most common case probably is that you want to make your IP look like it's coming from a location that's different than your current location. So in that case, you don't really care about logging stuff. So if I want to watch some, I don't know, soccer game and I have to be in the UK to watch it online, then I might geo-hop, as it's called. I might use a VPN to make it look like I'm coming from the UK so I can access BBC or whatever. So anyway, so that's the story there. Now, what about Tor? So what Tor is it's kind of like a network of VPNs. So you have a whole set of VPNs, or they don't use the language VPN, they call them relays. And what the user does is they configure their client to choose whatever, let's say three server nodes at random, okay? So they might decide, okay, I'm going to choose this one, I'm going to choose this one, and I'm going to choose this one. And then their browser operating system, we'll talk about that in more detail, but somehow their client is configured so that they send their information through 3 of these relays in a certain order. And then it pops out at Facebook or whoever. Okay, and then there's a way for the responses to come back. It's kind of complicated, but anyways, you can believe that there's some way that the information, and it comes back the exact same way it went. So here's the request. Here's the response. Now what it does in addition is it provides encryption. And so it, first off, let's just go back to this example. With a VPN, you could have encryption here if you wanted. So you could have encryption between you and the VPN. But you're not going to have encryption, at least not necessarily between you and Facebook. Now, or between the VPN and Facebook. So this would be like some sort of custom. Now, what if you did HTTPS? Okay, so let's say you're accessing Facebook over HTTPS. Do you have a secure tunnel all the way to Facebook, or does it go to the VPN and then the VPN forms a secure tunnel to Facebook? Okay, say again, but louder. Okay, so it could be like a man in the middle where you have pairwise encrypted tunnels. But HTTPS is actually end-to-end encryption. So what end-to-end encryption means is it gives you encryption all the way to Facebook. So the VPN, they see HTTPS traffic. So they see your request. They don't know what it is, right? It's encrypted. They know where it's coming from, and they know where it's going. Remember, we said that you can't hide that using HTTPS, otherwise packets can't find where they're supposed to go. But the content of the packet, you don't need, if you're just forwarding traffic, you don't need to know the content. Okay, so if you were to use HTTPS, you could still have a secure connection all the way to the end. So this would be like, try and draw this better. So if you had HTTPS, you would still, it would tunnel right through the VPN. Okay, so the VPN would see the outer layer of the packet, but it wouldn't be able to see the inside content. Now, we saw all those fingerprinting attacks and things like that, right? So the VPN still sees a lot of information. They see the size of packets. They know you're going to Facebook, even if they don't know what you're doing on Facebook. They know all the images and mixed content that gets weaved together. So, yeah. But anyways, and then the pink here would represent some sort of custom VPN encryption. And so VPN does, usually it generally, like a VPN server will have encryption between you and it. Okay, that's why it's called, that's the P. So VPN stands for virtual private network. And so there is a concept of a proxy. A proxy server is exactly the same as VPN, but it doesn't have that pink encryption. It just forwards everything, but you talk to it with plain text. But once you have encryption between you and the proxy, then we generally call it VPN as opposed to a proxy, but it's the same idea. Okay, so what Tor is going to do is it's going to do the same thing. What it's going to do is it's going to give you encryption, and I'm going to try and draw this really nicely if I can. So if you have HTTPS, then your encryption would go all the way through Tor, all the way through all the routers or relays, and it would end up at the server. In addition, Tor will give you encryption between you and every node that's between you and it. And the way it does it is it sort of tunnels encryption tunnels inside of encryption tunnels. So it will give you a big pipe that will go all the way to the last node. And that encrypted tunnel will be inside another encrypted tunnel that goes between you and the second node. So this gets kind of messy, but if you just watch me draw it, you'll at least get hopefully the idea. And then all of that is inside a big encrypted tunnel that goes between you and the first node and back. Okay. So this is where, so Tor well, it doesn't stand for anything, but originally it was set to stand for the onion router. And the idea of an onion is that you have encryption inside encryption inside encryption, and everyone is sort of peeling a layer off. So when your traffic between you and the first node is actually encrypted 4 times. Once for between you and the first node, once for you and the second node, once for you and the third node, and then if you're using HTTPS between you and the final website. The first node strips off 1 layer of encryption, so now your traffic's only encrypted 3 times. The second node strips off a layer of encryption, so now it's encrypted twice, and then the final node, the exit node, it will strip off another layer of encryption, and so now it's only encrypted once with HTTPS all the way to the website. Okay, all of this doesn't really matter. I just thought I would explain it for fun. But the main property here is, remember, if we have a VPN can keep a log, username, Facebook. No relay, every relay here can keep a log, but all they know is, let's take this relay here. If they want to keep a log, all they know is I got some traffic from, I'm going to call this R1 for relay 1, relay 2, and relay 3. So all their log is going to say is, hey, I was getting some traffic from R1 and I was sending it to R3, right? I have no clue. I don't know anything before R1, okay? So I don't know where R1 got it from. I don't know who Alice is. I have no idea where it's going. I sent it to R3. I don't know where it went after that. Maybe it went to another relay in Tor. Maybe it went on to a website. I have no idea. All I know is I saw traffic between R1 and R3. Similarly, R3, they kind of know more information because they know that ultimately this traffic went to Facebook, but they don't know where it came from. They only know, oh, it came from R2. Okay? And then similarly, R1, they know who the user is. But they only know that they were sending it to R2. Okay? And then Facebook, what Facebook sees is they see a request come out and it has the exit nodes, R3's IP address. Whoops. Okay, so let's say you want to know who was it that accessed Facebook at a certain time, right? What you would have to do is, or this is in the ideal case, what you would have to do is you would have to basically go find R3, get the log from R3, then find R2, get the log from them, then find R1, get the log from them. And then what Tor does deliberately is it puts its relays in different countries around the world. Okay, so you're not going to bounce through 3 servers in the US. You're going to go to the US, and then you're going to go to Europe, and then maybe to Asia, whatever, and then it ends up in the final traffic, wherever it ends up. Okay, so they deliberately do that so that it's really hard to break the anonymity of the system. And you don't have to use 3 nodes. You can use 5, you can use 7, you can use a VPN and then use Tor, whatever you want. It's a very flexible kind of protocol. Okay, now one thing I'll just tell a story because it's kind of funny. There was so this actually happened at Harvard University. So someone wanted to get out of writing an exam, and so they decided that they were going to report a bomb threat, or they were going to report a bomb, and it wasn't real. So they just made it up. It was a student, and so they said, "Oh, I have a good idea. Instead of calling up, it might be traceable. I'm going to send it through Tor. Okay, I'm going to email it to the administration, and I'll email it through Tor, and I'll use a fake Gmail account or whatever the case may be." So they did it. So they emailed it to Tor. Or sorry, they emailed it through Tor to the university. So what does the university see in this case?
The last IP address.
They see the last IP address. Okay, so they have no idea who the original person was. Okay, so there's no way they could trace that email, right?
I mean, if they can have access to the logs.
Okay, so let's say they can't. So the logs are, I don't know, they're in Europe somewhere, and it's a crime what the student did, but it's not that serious of a crime. So they're not going to get like the logs extradited from like another country or something like that. Anything else? Okay, well, first off, what they could do is, and this is probably their thought process, is, oh, we have the IP address of the person who emailed it, and then they realize, oh no, this is a Tor IP address. Okay, so the list of all the nodes on Tor have to be public because otherwise you can't find. Actually, that's not slightly untrue. There are some hidden Tor nodes that are used in countries that would deny lists, like all Tor relays. But anyways, forget about that. So basically, as long as you're not in like a country that's like filtering the internet, your list of nodes are all public. So Harvard knows this came from Tor, right? Just doesn't know, right? So who could have it ultimately come from? Could it come from anyone, anywhere in the world? Sort of, but it would have had to come from someone who was using Tor at that time.
Yeah.
Okay? So anonymity, the concept of anonymity, or the way to think about it, is you have a set. So if you're anonymous, you're always anonymous within a set, right? So someone in this room does something, well, we have a set of people. It's not someone that's outside the room, it was someone that was inside this room. We don't know who it is, but we do have a set of people that it could be. The anonymity set of Tor is all the Tor users that were using Tor at that time. Okay? So that's the first important distinction. So it's not truly anonymous, right? But it gives you this cover set. Okay? So then what Harvard did is they said, I wonder if anyone was using Tor from our Wi-Fi network at the time that this email got sent, right? How would they know that? Okay, so remember the R1 here, right? They know the true user IP, and R1 itself is also a Tor node. Okay, so if they control the Wi-Fi, then they can look at, what's all the traffic that's going from any user to any R1 that's on Tor. Okay, so they could see every user that was on Tor at that time, and they know that the email came out of Tor. So when they looked, turns out Tor's not that popular at Harvard, and there was only one user who was on the network at that time. And so they couldn't prove it, right? Because maybe that user was someone different, right? That just happened to be using Tor. And the real person, they were using Tor, but not from Harvard's network. They were at the Starbucks across the street or something like that. But anyways, they brought them in, they questioned them, and then the student admitted to doing it. And so they caught them. So anyway, so that shows you that there's subtleties. You have to have the right mental model, right, of this. It's easy to make mistakes using the software because you just think, it's bulletproof, right? There's these 3 routers. You have to compromise all 3 of them. If you can't do that, then no one can ever tell anything, right? But when you understand the system and the details, then you start to realize, oh, there are like certain things that you could tell. Just like HTTPS, right? Like it looks bulletproof, but then there's actually turns out there's a lot you can tell just by looking at the just at the outside of the packet. So Tor's sort of like that as well. Yeah.
I have some questions.
Yes, please.
One of them is the who are the nodes.
Mm-hmm.
It's for
Good question.
like torrent, torrent, each person has maybe
Yeah.
my IP address, I joined them or no?
Yeah, okay, so the list of Tor nodes are volunteers. So they're people who just volunteer, they throw a server up, and and then they get added to the list. So you don't actually know who they are. You can sort of be reasonably sure of where they are, but you don't really know. You're just choosing from a random list. Could law enforcement run Tor nodes? Almost certainly they do, right?
If these students send the email outside the university, they don't.
Yeah, that's right, exactly. So had that Harvard example, if they had just gone across the street to Starbucks and used the Starbucks Wi-Fi, then they would have got away with it.
And
Yeah.
another question.
The other thing, can I just circle back to who the nodes are? So they are random, they're volunteers, but at the same time, Tor has a face. Like there's people that run Tor, and the people who volunteer on the network often, like they're not hiding, right? Like for example, the university that I was at, they have a Tor server, right? And so they make it known. And the person who runs Tor, like the person, the main person that runs the project, he personally knows the person at Waterloo that runs the Tor node kind of thing. And so it's not like just a complete random set of nodes. A lot of them are sort of like people know the people that run them and things like that. But yeah.
Another question, if I join the Tor and I use the Tor, I will be one of the node or not?
No. So, well, you can choose. So you can choose to volunteer to be a node. But by default, when you use Tor, you're just a user. So you're sending your traffic into Tor. And normally you wouldn't run Tor as a node from a normal computer. You would have to set up like a network or like big infrastructure and things like that. So in the early days of Tor, I think it was perceived more as a peer-to-peer thing where like it was easy, like you could just click a button and then become a Tor node. But now because bandwidth is so big and you need infrastructure and things like that, I'm sure that the software to be a server is completely different than the software to be a client.
Another question, when we disconnected Tor, I used the same like you 15 years ago.
Mhm.
I did the new one. I know the Tor, and we can check, for example, BBC and
Yep.
on the website. And when we disconnect web browser, we open again, we randomly choose the Tor randomly choose one node. Yeah.
Yeah. So the way Tor works, I don't know the exact configuration, but I believe it's on a timer. And so I think every 10 minutes it tears down the circuit and then changes it. Yeah.
And the last time I used for Echo Shoes, Echo has a promotion
Yeah.
on the website. When I click on my browser, it knows I am, and they don't give me the promotion. When I use the Tor, another IP address, which 10 seconds, and I can take the
Right.
my chance.
So that works. But then once any Tor user uses it enough, then eventually all Tor nodes will have visited that website.
When I
Kind of
click
thing,
on
but-
open again, I have another IP address.
Yeah, exactly. So you can reset your circuit, you'll get a new exit node, and then the website's going to see a new IP address. And so you could sit there and do it until you run out of exit nodes.
And another question about VPNs. I see some VPNs, for example, I want to download the torrent file.
Mm-hmm.
Some VPNs doesn't support the torrent, but some of them support it.
Yeah.
What is different between them?
Okay, so BitTorrent runs, first off, it generally runs on a specific port, so it's easy to identify. But even if you set up a custom port, then there's going to be header files and things like that, and then you can look at it. And then you can wrap it in encryption, and then maybe you can get it so that like you can thwart their like packet sniffing basically. So if they do deep packet analysis, they can probably figure it out. But if they're just doing shallow, like kind of surface level, you could encrypt it and go to a non-standard port, and then you could run BitTorrent. And then the question is, why do they do it? It's just because it's high bandwidth.
Some of them support, some of them doesn't support.
Yeah. So it's a bandwidth question. So it costs them money like the more bandwidth you consume, the more money they're paying, and so it depends on whether they want to support it or not. Yeah. So Tor is notoriously slow. You'll see it. But it's more slow in terms of latency. So like you ask for something, it takes a long time to get a request. But if you're downloading a large file, it's going to start, like it's going to take a long time to start. But once it starts streaming, it's going to come to you fast. Like it won't slow down your download speed. It doesn't affect the bandwidth. It just affects the latency itself. But yeah, I thought I'd throw that out too.
And the last
Yeah.
question, when, for example, I use VPN, when they hack the VPN server,
Yeah.
everything,
Yeah.
who connected to this VPN?
So it depends on the VPN themselves. So the VPN may or may not keep those logs. So some of them are like, yeah, we could keep the logs, but we don't. Like we promise that we don't keep the logs.
But we don't know.
But you don't know.
Maybe they
Exactly. At least with Tor, you know that even in the worst case, they do keep the logs, you still have to compromise 3 of them. Yeah.
Could you explain that again about this tables, R1 and R3?
Yeah. So R1, R2, R3 are the 3 Tor nodes that you route through.
Yeah.
And so basically, you don't have to look at the tables, just look at the picture. R2 only knows about, it got something from R1 and it's giving it to R3.
Yeah.
And similarly, R3 knows it got something from R2 and it's sending it to Facebook. Yeah, so everyone just knows their nearest neighbor. They don't know the full path.
Here R1 and R3, but I couldn't find R1 and R3.
Yeah, so R1 is here and R3 is here.
But, yes.
Yeah?
Yeah.
Okay.
Thank you very much.
Okay, no problem. And then, so go back to your example. So let's say Iran decided to ban all Tor nodes, which it probably has, right? Then how do you use Tor in a country like that? And so the answer is that you can't. Basically, there's no technical solution to it. But what the Tor project does is they offer these like kind of bridge nodes that are kind of outside of the Tor network, but they can feed traffic into the Tor network. And the way you get knowledge of a bridge node is just like by word of mouth. So they might work with like certain organizations within a country to share some of these bridge node IP addresses. And so yeah, so that they do it in China, for example, and I assume in Iran and other countries like that have restrictive internet. Okay, any other questions about Tor, how it works? Okay, so let's try it out. So the first thing we need to do if we're doing a cognitive walkthrough is we need to define a set of core tasks. So we're not going to evaluate every single thing. We're not going to go through the user interface and look at every menu and everything. We're just going to say most users, they want to do a certain set of things. So let's just walk through that process and evaluate it in terms of those tasks. So the core tasks that I did when I did the project, we'll just borrow them. They're like the 4 most basic things that you could do. So successfully install Tor and the components that you need. So Tor used to work. It worked a lot different 15 years ago. It required you to install 3 or 4 things. Now it's, as you'll see, you just get one bundle and it does everything for you, which is nice. Then you have to configure, basically make sure that Tor is working. And so it used to be the case that you would use your normal browser. So you use Safari, Chrome, whatever you use. You'd have Tor running and then you'd have to get the 2 to talk to each other. And that was like a bit of a nightmare. So now what Tor does is they actually just give you a browser. So you download a browser and the browser is Tor. It's a Firefox variant and it just works with it. So it makes this a lot simpler. Then you want to make sure like, okay, how do I know it's working? Is it working or not? How do I know it? And then you want to be able to disable it, know that it's disabled, and return to your normal like direct connection. Okay. Then the second thing we need for a cognitive walkthrough before we actually start doing it is we need a set of guidelines or heuristics. by the way, this paper, if you want it, it's on the course website. So it's called Tor Study here, and so I just what I'm putting in there is just copy and pasted out of it. So, okay, so the guidelines that we'll use are the following. Okay, so I'll go through them. We'll refer back to them as we do the actual thing, and I'll write down. I'm just going to write down some notes. We'll mainly just talk through it, but I'll scribble down a few things, maybe take some screenshots. But I'll just refer to G1 through G8. These sets of guidelines work actually well for software. So this isn't really, these weren't guidelines that were written with Tor in mind. They weren't even written with security in mind per se. They just generally work. Actually, I should say they were written with security in mind, but not all the guidelines concern security. And so they are a pretty general set of tests. Okay, so the first one is that users need to know, like, they want to do a core task, so they want to get Tor to run, okay? They need to know what they have to do, right? How do I get Tor to run? Like, I have to go to the website, I have to download the software, and then I guess I'll just figure it out as I install it and try and figure it out, okay? So they should be able to determine how to perform these steps. And once they've done one of the steps along the way, then they should know that, okay, I'm done, okay? It was successful, I can move on to another kind of core task. Now, as they navigate through the process, they shouldn't make errors, okay? And this is where you're going to put your hat on as, I know a bit about Tor, like the Harvard bomber or whatever, right? That's an error. They made an error, right? And so you need to foresee that error is possible, and then you have to see if the interface would make it easy for some user to commit an error like that, okay? And you can sort of split them into like what I call G4 and G5. So G4 is just sort of like not critical error, or it's an error that you can recover from, right? So you can make the error, you can figure it wrong, but you can go back and reconfigure it if you figure out. And then G5 is like, you made a mistake, it's too late. Like, you sent that email, it's gone, right? And even if you figure out after, oh, like, oops, I should have not sent it from the Wi-Fi network, it's too late. That email's gone, the IP address is on it, your IP address connected to Tor is there, it's over, kind of thing. So that's like a dangerous error, is basically an error that you can't recover from. You should be comfortable with the terminology. So sometimes we say jargon. So jargon is like, words, like technical words that a normal user wouldn't understand. You should be comfortable with the interface. So if there's anything about the interface that's kind of weird, that might make users uncomfortable, you could note that or flag it. And then you should be aware of the status at all times. Okay, so you should know, like, am I done? Is it working? Is it anonymizing? Is it not anonymizing? Like, what's the status of what's going on? Okay, so basically what you'll do is you'll go through the core task. So you'll put yourself in the shoes of a user that's going to install Tor and the components in question. And then you're just going to flag issues. So if you see an issue with jargon, then you would write down, there's this issue and it violates G6, which is the jargon one, okay? And as you go through the process, you can flag both good things and bad things. So generally, the reason you're doing it is you want to flag the bad things, right? That's the whole purpose. But sometimes if you want, you see something you really like and you're like, oh, they did a really good job of this, then you could also make a note of good things as well. So yeah. Okay, so let's try and do this. All right, so core task 1 is basically, let's get it installed. Okay, so how do I install Tor?
The first.
Okay, I'm going to take the first thing I heard, which is Google it. All right. Now, most people wouldn't even necessarily Google Tor. They might not even know what Tor is. Okay, so they might Google, like, I don't know. What would you Google if you wanted something like Tor?
I searched Google.
Is Anonymous even like a...
Tor, Wikipedia. The first I understand what is the Tor. After.
Sure, but would you even use the term anonymity, or is that too technical? Yeah, so you could do secure browsing. Let's just see for fun. So we get lots of stuff. Google safe browsing. Things about tracking. I don't see anything about Tor. If you knew about Anonymous, you could say... So I'm sure if we read some of these listicles, they would list Tor. So private browsing probably wouldn't bring it up. We can try it, but recall private browsing actually is something different, right? So private browsing is like when you go like this. So now I have a private browser window. What does that do? Anyways, I'm curious. Does anyone know?
Doesn't take the cache.
Okay, so it doesn't keep the cache, but that's something that's on your computer anyway, so no one knows what's in your cache or not.
The history isn't saved. It's the same.
So it doesn't hide your history. Yeah, or sorry, it doesn't save your history. So when you close the browser window, then your history goes away. So if your threat model is like someone else sitting down at your computer and trying to figure out what you were doing on it, that's where this could help. There's another thing it does that's probably more important. It resets your cookies. Okay, so right now I have an empty cookie jar. So even if I go to websites that I'm like, keep me logged in, when I do it from here, I'm going to be completely logged out. Okay, and as I use it, I will build up new cookies. Okay, so it's not like cookies are disabled, it's just they're reset. So it's like I bought a brand new computer, I turned it on for the first time, and then as I use it, I'll accumulate cookies, but then once I close it, then all the cookies are gone. And if I open another one, then I would get it as well. All right, so anyways, if we search for anonymous browsing, we do find Tor eventually. So it's here. Okay, so this is the website. So they have it pretty prominent here, download Tor Browser. I don't know if there could be any more obvious. It does tell you a bit about the kinds of things that it does. So it blocks trackers. This actually, to be technical, doesn't have anything to do with Tor. So Tor doesn't do anything about trackers specifically, but usually when you get the Tor browser bundle, it comes bundled with other privacy tools as well. So it's not the whole proxy network thing that's helping with this. It's the other stuff that they have in the Tor browser. This is mainly what Tor is going to do. This is actually interesting. So just for your own curiosity, where's our picture? So let's say that you have two users, Alice and Bob, and they're both using Tor, right? Could you tell them apart? So you can't tell them apart based on their IP address. Is there any other way that you could tell them apart? So you saw the word fingerprinting. What does that mean? That's the right answer.
Basically, see what websites they're visiting, and then you could check
Okay, so let me clarify. By they, I mean, I should have said it a bit more explicit. Could Facebook tell the difference between Alice and Bob? So let's say Alice and Bob are both using Tor, and you are Facebook in this case. You're not Tor trying to figure out who it is. You're Facebook. Can Facebook figure out whether it's Alice or Bob?
Yes, sure.
Okay, so the answer is yes, fingerprinting, but anyone have an idea of what that means?
Because Facebook is the one that issue cookies, so of course it knows that this cookie belongs to Bob and this cookie belongs to Alice.
Okay, so let's say that the person's not logged in at all, and Tor does a private browser window, something like that, or when you start using Tor, then it clears your cookies. I can formulate the question maybe a little bit easier, but it won't help you with the answer. Let's say that Alice goes to Tor today. Okay. Tomorrow, Alice goes to Facebook over Tor yesterday. Okay. Today, Alice and Bob are both on, or somebody, let's just say someone shows up at Facebook. Is that Alice from yesterday, or is it a brand new person, Bob? Right. That's basically what Facebook wants to answer. So if it had a cookie and it put it in Alice's computer and she maintained that session, then it would say, oh, that's the same person from yesterday. Maybe I don't know it's Alice, I don't know her name, but I know that it's the same person. But let's assume the cookies are cleared. Is there any other way I could tell? So what can Facebook actually do? Right? They can look at the packets. The packets have IP addresses. There's not really anything else that's identifiable on them. Is there anything else Facebook can do? So they can control the website that comes down, right? And the website that comes down, it could have things like JavaScript in it. Okay, what can JavaScript do? Could JavaScript ask for the IP address? So it turns out the answer is yes. Okay, so JavaScript can just say what's the IP address, and then the browser will say, oh, my IP address is blah blah blah, and then JavaScript can phone that home to Facebook. Okay, so scripting's bad. Another thing you might do is you might say, well, I'm Facebook, I want my website to look pretty, so I want to know, like, I have a custom font. Do they have it installed? What's the dimensions of their screen, right? Because do I give them the mobile version or do I give them the desktop version? Okay, so there's all these things that you're permitted to ask as a website, and it turns out that everyone has kind of a unique configuration, right? So even if you have the exact same, we both have MacBook Airs, depending on what websites I've browsed in the past, I'll have a different set of fonts and other like little configurations that are going to look a little bit different than yours. Okay, so anyway, so you can fingerprint all of that, and then you can actually tell users apart. So another thing that Tor does is because they give you a browser, they make sure that every copy of the Tor browser has the exact same fonts installed, the exact same screen dimensions, and things like that. And it won't, as you visit websites, it's not going to change that configuration. It's always going to respond with the same thing. So anyway, so that's another thing that Tor does. Whatever. So, and then the multi-layered encryption is what I sort of tried to draw out. It was kind of hard. And then, anyways, browse freely. Okay, so let's install it. So we're going to download Tor Browser. I'm going to download it for Mac OS. And now I remember that I should actually do this before class, because now I have to kill a minute talking about something. While we wait out, let me just make a quick list of some of the random things that we talked about, just so that if you're only looking at the notes, you'll remember that there's audio that covers them. So we talked about anonymity sets. I don't know why this pen's not working. That was like the Harvard bomb. And we talked about fingerprinting. Browsers. Okay, so we're done. I'm going to open it up. Okay, so this is a pretty standard kind of Apple installation. If you use Apple, you'll sort of recognize what you see. All right, so basically all I did is I Googled it. There was a download link that was pretty prominent. And then the installer was just kind of standard. Okay, so do I think a normal user would be able to follow all of these steps? Probably. I don't really foresee a problem. So G1, G2, G3 are pretty much okay. Up to this point anyways. Okay, how do I actually install this now?
Right.
All right, so you drag it. So that's kind of weird, right? But anyways, if you use Apple, you're used to that. Sometimes they make it more obvious, like they have like a picture where they're like, drag this here kind of thing. But. Okay, so success, it's installed, so let's run it. Okay, so first thing I do is I get a little error. Tor Browser is an app downloaded from the internet. Are you sure you want to run it? Safari downloaded this file today from Tor project. Apple checked it for malicious software and none was detected. So this is the kind of thing that, this is actually Apple's doing. Is there anything that Tor could do to avoid this popping up? Anyone know?
Use a different download provider.
Not sort of, yeah. So what they could do is they could register with Apple and have a software certificate and sign it with it. And then if they distribute it through the App Store or something like that, then you could suppress this warning. Can't seem to move these pictures once I drop them in. But anyways, so this could be suppressed. Apologize for the writing. It's like 90% of the time this works, but sometimes it just lags. Suppress by, registering. Okay, so let's open this. Okay, so this is new. I haven't seen this since from 2 years ago, but it's actually really nice. I like what I'm seeing. Okay, so the very first screen basically says, okay, so Tor Browser routes your traffic over the Tor network run by thousands of volunteers around the world. Okay, is that understandable? Yeah, okay, so it's good on jargon, which is G6. Okay, it's a nice, simple way of explaining it. It gets to the main point. And then remember that the core task, one core task is you should always know the next step that you want to do. And once you're done it, you should know that it worked or whatever. Okay. So this is very explicit. Right now, I assume reading this, I am not on Tor. Right? It's asking me to connect to the network. So I assume that right now, before I interface with this dialog, that I'm not actually connected to Tor. Reasonable? Okay. So I'm aware of the status. So I know that my core task isn't completed. Okay. So it's great on G8. So this is aware of status, and the status is not connected. Now I want to get connected. Okay. So that's, we're already installed it, so we're on to, I mean, core tasks 1 and 2 are sort of done. So this is concerning core task 3 now, which is get yourself connected, make sure, and then confirm that your stuff is being anonymized. Okay, is it clear what I do to actually connect? Do I know what that next step is? So it's pretty obvious, right? I click connect, and then now I think I'm going to be connected. So I at least know what the next step is that I should do. Okay? So the next step is clear. So that's G2. All right, so I'm just going to connect. And actually, let me go back. Oh yeah, okay. So another thing to notice is that they don't give you an option to, you can't be like cancel or something like that. Like I don't want to connect, right? So like imagine they had a cancel, then what? It would just be a browser, but you wouldn't be on Tor, right? So like basically you can only connect, or you can change your network settings, right? And I can't go up here, I can't start, well, let's just try it and see what happens. So if I try to navigate without connecting to the network, then it's going to stop me from doing it as well. Okay. So it also avoids, sort of click-throughs where people are just clicking on stuff, trying to, not reading. We're just going to click on it. We click the purple button, it does what we want it. If we click the gray button, we'll see. I'll click it. But if we just start using the browser and just ignore it, then it's not going to work as well. Okay. So there's no click-through. There's no way to commit a dangerous error. So it's good in terms of G4, G5. I don't know whether they're critical layers or not, but it's good in terms of G4, G5. Now, just for fun, let's just see what happens here. So if we go here, these are all the different settings. And so it's going to set, it's going to come up with a set of defaults. So we mentioned in class, another principle of usability is your defaults are important. So let's just take a look for fun. I haven't looked at it for a bit. So there's stuff about whether you want it to be a default browser. This is not really privacy or security related. .onion sites we won't explain. Cookies. So you'll notice here they say it's in permanent private browsing mode. Cookies and site data will always be cleared when the Tor browser is closed. Okay, so that's trying to give you some information about the status of the application at all times. Okay, so that's concerning with G8. And knowing how to sometimes you set something up and you know that it's working, but then you're not sure when it stops working. Okay, that's another important thing. So like I got my encryption, it's going, but like is it going to go for the rest of the day? Is it going to go till tomorrow? Like when does it stop, right? What's the action that I would take to stop it? That's also important. So here it's very clear that your cookies are going to accumulate, but when you close the browser window, that's the event that stops that accumulation of cookies. Okay, and then Tor settings, so you can always connect automatically. This bridge things is what I mentioned. If you're in a place where the Tor network as a whole is blocked, then you have the option of putting a bridge in. And if you use a proxy, there's advanced configurations and this type of thing as well. So all this stuff is turned off. It used to be the case in previous years that it would actually walk you through a wizard that would ask you all these questions about this stuff. So it would be like, okay, are you on a proxy or not? And then we used to criticize it for using jargon, and it's not really clear what it's asking and things like that. But now that I've used it a few years later, they now just they built it into the default settings. And like most people aren't going to use a bridge, most people aren't going to use a proxy, and so it makes sense to just have the default, like what works for 99% of people. Okay. Yeah, so next year I might have to choose a different software to look at because I'm running out of things to criticize. But anyways, let's connect. So you'll notice a cancel button. If I click it, it just goes back to this screen, so it doesn't bypass it.
I'm not sure if it will work that well for you.
So that's also a issue that I've had in the past. So we'll just give it a second and okay, so what I'm going to do is I'm going to try and hotspot through my phone. See if it will work that way instead. Okay, so yeah, so Concordia was blocking it. Now it seems to be making more progress. So we do have this nice progress bar at the top. Seems like it's working. So like it could have, you notice it took a bit of time. I don't know what your mental model was of how long it would take, but it wasn't instant. But because of that progress bar, you got a sense that it was doing something. It didn't freeze up, it didn't hang. But actually in contrast, because when I clicked it with Concordia, it did hang, right? And I didn't know, like, is it never going to work, right? And one thing that would have been fun, I guess, not for you to watch, but to maybe hang on for a minute and see what it does. My suspicion is that probably it would just never do anything, right? Like it would have just hung at that stage. So that's actually something that they could they could do to enhance usability. So if Tor is blocked, when you click on connect, it hangs. Okay, so the user doesn't know. Now, it's not going to let you do something dangerous while it's hanging. Okay, so that's good. Okay, so it's still good in terms of like G4, G5. Okay, but in terms of do I know the status? I don't really know the status. I know I asked it to connect, and I know it's not. It's seemingly not connected, but I don't know why. You know, eventually it could time out, and then it could give me like some sort of sensible warning, or like it looks like your internet isn't isn't configured to use Tor, or we tried to connect to the Tor network from your connection, and it's obvious that it doesn't work, and so talk to your site administrator. I don't know. There's lots of things like that. So anyway, so that's one small thing that could be better. Okay, so now I'm connected. All right. How do I know that I'm connected? Is my traffic now anonymized?
just on the web.
Say again, sorry.
Just on the web.
So there's a question of what is anonymized, but what I'm seeing in the browser window here. So let me type something in. So I type in Montreal Impact. Actually, there's CF Montreal now. Okay. First, you'll notice that it's a little bit slow, right? Why? Because it's going to Europe and US and different places. Okay. Was that anonymous?
Compare the IP addresses.
Yeah,
Yeah.
because
Should be.
it never asked us to log in or.
Okay.
Maybe if you search the normal browser, shows some CA maybe,
Mm-hmm.
.com. Maybe it's connected to another country, and after that, the browser thought the search engine thought you comes to another browser, maybe
Okay.
another country.
So we don't know where the traffic went,
No.
but do we think do you actually think that went over Tor?
DuckDuckGo is a private browser, so private opinion. So I think it's a private. We can
Okay.
try.
Who thinks that went over Tor?
Judging by the speed, yeah.
Okay, put your hand up. Okay, who doesn't think? Okay, who has no opinion? Okay, pick a side. Okay? It's a simple question. You can be wrong, doesn't matter. Do you think yes? Okay? Do you think no? I still see people who didn't put their hand up. Okay? Pick yes or no. All right? Everyone stand up. Everyone stand up. Stand up. Seriously, stand up. If you think yes, sit down. If you think no, stand up. Okay, good. So you can sit down now. All right. At least I forced everyone to take an opinion. Okay, did that go over Tor or not? I don't know. So how would the user figure it out? So one thing, yeah, go ahead. Okay, so we could go looking in the user interface to try and figure out whether it's on Tor or not. Okay, so what I would expect is some queue. Okay, now the other thing though is that the setup did say, do you want to connect to the network? And I said yes. Then it did something. I assume that connected me to the network as well. Okay, but yeah. So are we sure that we are on Tor? Okay, so I'll note that there was some uncertainty even in the class. So G8, we're not sure the status. Also, we should know that we successfully completed the task. So the core task we're trying to do is to confirm, to basically configure it so that we could be anonymous and then confirm that it was anonymous. So it's sort of a G3 and G8 issue. There's no obvious user queue. So this would be, user queues are sort of G7. G7's like, are you comfortable with the interface? So a queue is like a picture or something. So it could say like, you are now anonymous, right? Somewhere on the Chrome or something and make it very explicit. So we don't have that, okay? So then we can go and we can dig through the interface. Now, by the way, the answer is yes. So this is over Tor. The mental model of Tor is that if you're in the browser, it's anonymous. So like if it's working and you are connected to a website and you're getting something back, then yes, it is going through Tor. There's no way to force this software to connect to the internet not over Tor. Either it's not going to work, like it will keep asking you to connect. So it's either doesn't work at all or it works, and then when it works, it's anonymous. But you know, it could do better on communicating that to the users. Okay, so we can go look at the lock, and we'll get a bit more information here. So this is the lock interface. Okay, so the first thing is it says this connection is secure. We can even click on that to get more information. Does that mean it's anonymous? What does secure mean in this case? That means it's over Tor. So in this case, it actually just means it's over HTTPS. Okay, so you'll notice that this site is over HTTPS. So what it's doing is it's actually bundling some information about HTTPS with some information of Tor. Is that confusing? I don't know, maybe, right? Maybe they should show you the stuff about Tor separate from the stuff about HTTPS. Or maybe if you understand anything about Tor and HTTPS, you know enough to keep them separate. I don't know. But it's something that you could think about. Right, so it conflates Tor and HTTPS info. Okay, now you do see actual information about Tor. Okay, and it actually has a pretty nice kind of thing here where it tells you, okay, I have 3 nodes. So here's my browser here. First, the entry node is in Finland in Europe. Then I'm going to go to one node in the US. Then I'm going to go to another node in the US. And then I'm going to the actual website, DuckDuckGo, which is the default search engine for it. I can change the circuit. So there was a question about like if you can refresh it. So let's just try it. I'm just going to close Safari because I keep flipping to it. So if at any time I want a different circuit, I just click it. So now I'm, and the website refresh. So now it goes to Finland, then it goes to Sweden, and then it goes to Germany. Say again?
What do they mean by God next to Finland?
Yeah, okay, so that's something that maybe the user would know. Yeah, so the guard is actually just a fancy name for the first node. So the first node they always call the guard. They used to call it entry guard is so this is called the entry guard. And this sometimes, I don't know if Tor themselves call it, but it's often called the exit node. So it's just terminology for those 2 nodes, and then you have your middle nodes or whatever. Entry guard, in this case, it goes back to like sometimes like Roger Dingledime, who runs the Tor project, personally knows Ian Goldberg at the University of Waterloo, who's running the Tor server for Waterloo, right? And in this case, Waterloo actually asks explicitly to be a middle node, because if you're an exit node, you know, let's say someone goes and does something illicit on the internet, your IP address is showing up. Okay, so it's a liability. And then entry nodes has its own set of problems. But anyways, if there's that personal relationship, then Roger might add you to the entry guard program. And it basically says, I know, like I have some relationship with the person running the server. I trust them. It doesn't mean you should trust them, but they're not just some completely random server on the internet, okay? Whereas your middle node, your exit node could be those random servers, okay? So there's more like kind of human discretion that's involved in choosing the entrance node than all the other nodes on Tor. So anyway, so that's what it shows you. As mentioned, the guard is always the first node. And then they say that the guard might not change. If you want to learn more, you can. And I'm sure it will be a sort of super technical article that let's see what it says. This is normal Tor behavior. The first relay in your circuit is called the entry guard or guard. It's fast and stable. Oh yeah, so that's the other thing is they have some stability requirements and things like that. Anyways, they have a paper that you can read about it. Let's just skip over that. Okay, so anyways, if the user found their way to this box, then they would probably conclude that they are connected to Tor. At least it tries to paint that picture of it being connected. We can just look and see what other stuff there is kind of up here. So we have this standard security level. And, oh, this is interesting. So they have 3 different settings in terms of security level. So this is basically going to have to do with whether you're going to allow JavaScript and other client-side scripting, and then some stuff that could be used for fingerprinting. So JavaScript is probably the most important thing to sort of talk about. So JavaScript is tricky because lots of websites use it. So if Tor decides that they're going to disable JavaScript by default, then a lot of the web's not going to work. On the contrast, JavaScript can ask the IP address just from the browser and get it. And so Tor doesn't want to enable it because then the website people, they'll say, oh, there's traffic from Tor. No problem. I'll just throw some JavaScript in and figure out what their IP address is. And then it's as if they're not using Tor as well. So what they do is I guess they have different sort of graduated levels of it. But I'll note that JavaScript and client-side scripting is dangerous. Now, they may do other provisions as well. So I shouldn't say, I'll say that it could leak IP address, but it maybe they change the browser so like when the request is made, they forge it, or there's different things they could do at the browser level probably to stop this from happening. I'd have to think about whether they can be circumvented or not. But anyways, yeah. So anyways, I'm not saying for sure that if you have JavaScript running that you can always get the IP address, but there is the functionality to ask for it, but that functionality is going to go through the browser. They control the browser, so they'll have some control over it as well. Okay, the other thing I'll just note quickly, I know we're a little overdue for a break, but I just want to wrap this up so we can do something different when we come back. Is what actually, so another dangerous error, I guess, that a user might make. Dangerous errors G5, sorry. Okay, so I have Tor, I opened it up, it's working. Now I want to go down to FTP, or I want to open up my messages or whatever it is. And because Tor is running, they're going to be anonymous too, right?
No.
Why not?
Because it's just web browser.
Okay. So you run Tor, does that mean all traffic is anonymous? And the answer is no, just the browser. So if I want to do my BitTorrent over Tor, if I want to, use BitTorrent, download some files over Tor, can I do it?
No.
Okay, so I can't, yeah, so the more complicated answer is I can't, at least with the browser, but Tor offers other software and software you can route different things through it. So the user has a client, which is their entire operating system. And in this case, you have the Tor browser. And so everything here is anonymous. But if I open Safari, maybe I have both windows open and then I accidentally start typing in the wrong window. if I use another app. Then these are not anonymous. Not through Tor. Okay, one other just small complication. So whatever, I went to DuckDuckGo. In order to go to DuckDuckGo, I had to get the IP address of DuckDuckGo. How do I do that? Who does DNS? Like, is it handled by the operating system or the browser? So it's actually the operating system. So it's going to get passed down from the browser to the operating system. The operating system is going to go to DNS. Did my DNS query go over Tor or not? If it doesn't, that would be a problem, right?
No, it's not over Tor.
Okay, so it seems like it wouldn't be over Tor, right? And that's a problem because even though people don't know what I'm doing on the websites, they do know which websites I'm going to, right? And so, yeah, the question is this anonymous or not? And so actually the answer is it is anonymous. So they do take care of hooking. So when you install the Tor browser bundle, they hook your DNS requests so that it goes over Tor as well. So they hook in everything for your browser, and then they also hook in DNS. The reason I just brought this up is when I looked at it like 15 years ago, you had to install a separate piece of software to hook all your DNS requests. So it was a real nightmare. You would get Tor, and then you'd have to configure your browser to connect to Tor instead of connecting directly. And then you'd have to configure another thing called Privoxy to hook your DNS requests. And like it was just a nightmare to set up. So now Tor looks like amazing compared to the way it used to look. But yeah.
Sorry, for privacy, did you mention that DNS is preferable if it's handled by the actual operating system or by Tor?
Sorry, is it preferable meaning?
Like which party should handle it?
Oh, so the operating system handles it, period.
Okay.
So the browser doesn't have a choice. But because you're installing software on the computer, you can install more than a browser. So you can install something that also hooks DNS as well. Yeah, yeah.
Can you tell us how technically it hooks the DNS from Tor?
So it would, when it does a DNS request, it will, okay, this is my guess. This is how Privoxy works, so I assume they're doing the same thing. When you start the Tor browser bundle, it would start a server on your computer that's running on localhost or something like that. And then the browser would be configured to send DNS over to local hosts on a certain port. That thing would be listening. And then once it got the request, then it would route it to Tor as opposed to routing it to the operating system. So yeah. So that's basically what you used to have to do that manually, but now it's happens automatically, without you knowing anything about it. At least that's my understanding. Maybe it's the case that DNS is, but I would be shocked if DNS wasn't, because that was like a core principle of how Tor worked, and one of the things that made it complicated. So I'm assuming, but I don't even know how I would confirm it other than sniffing like a packet sniffer. I'm not sure how I would confirm that actually DNS is being routed over Tor. But. Okay, any questions or comments about this? Yeah.
One question.
Yeah.
I thought about it. If we use VPN and also Tor, what
Yeah.
happens?
Nothing. It's just you. Your entrance node. So you can decide whether you want to use it before or after Tor, right?
Yeah.
So you can do either. And so if you use it before Tor, then you'll just go to your VPN, and then your VPN will forward it to Tor. And if you use it after, the same thing. So it will go through Tor first, then it will hit the VPN, and then it will end up at Facebook. So why would you want to use both? The main reason is you want the anonymity, so you use Tor, and you want the geo-hopping, so you use a VPN. So in Tor, you can be like, hey, I need a server in Norway because I want to watch Norwegian television, right? Maybe you can request that. but they don't necessarily have exit nodes in every country, right? But you could use a VPN at the last hop, right? So that, because there's VPNs, there's a lot more VPNs than there are Tor exit nodes, right? So you could, and then you have the anonymity. So even if the VPN logs get leaked, then all the VPN knows is that someone on Tor was asking for the information. Yeah. No worries. Okay, let's take that break. So come back at 7:25. Okay, just two more brief things about Tor. The first thing is it won't stop you from revealing your own identity. So what I mean by that is, let's say you go to Facebook, you're anonymous, it doesn't know who you are, your cookies have been reset, it doesn't recognize your IP address, but then you log in, right? Then now Facebook knows who you are, right? They know you're a Tor user too. So, there's nothing you can do at a browser level to stop that, right? If the user wants to log in, then they're going to log in. Or if they buy something and they fill out their name or address or something like that. So Tor can't do anything at that level. And then Core Task 4 we didn't actually talk about, but it's how do you disable it and return to normal browsing. And so the way it's set up now, once again, these core tasks are sort of old because they're based on how it was working 15 years ago. But 15 years ago, it was harder because you would have to sort of tear down your connection manually. And the way it was, the mental model back then was that you would have one browser. Sometimes you'd be on Tor and sometimes you wouldn't. So it'd be configured to use Tor. And then when you're done with Tor, then you would unconfigure it. And so you had to basically get it back to normal. But now it's like you have two browsers. So you have the Tor browser. If you're in that window, you're on Tor. And you have your Safari or Chrome or whatever. And if you're in that window, then you're not on Tor. And so if you want to switch between them, you just switch browser windows. If you're done with Tor, you close it. You're not. Okay. So it's a much simpler mental model now. And so that looks a lot nicer. Okay. Any questions about Tor before we move on, or questions about usability? So you will do this for assignment 2. So I'll ask you, I'll give you, probably this is the way it will look at, this is how we've done it in the past. I'll give you a tool that's somehow security related or privacy related, and then I'll ask you to do a walkthrough of it. And usually you could use the same guidelines, but you define your own core tasks. I think that's how we've done it in the past. I don't remember exactly, but anyways. The core part is that you will actually do the walkthrough, and then you'll note things that it does good and things it does bad in terms of all of these guidelines. Okay. So once again, what we do in class, just like the evaluation framework, we did an example in class. It was kind of super high level. Like your assignment, you had to be more detailed and careful. And then there's the academic paper, and that's the gold standard. So same thing with this. We did something in class. It was sort of sketchy. With the assignments, you'll have to be a little more precise as you go through a methodological. And then if you want to read what an academic paper looks like, you can read the Tor paper, or there's lots of cognitive walkthroughs of all sorts of different things to see what that looks like. So for the assignment, you might want to look through the cognitive walkthrough just to get a sense of kind of what it looks like when it's written up. But anyways, you at least are familiar with what you have to do. Okay. Final chance for any questions or comments.